Thank you, everyone. I'm going to try to speak loud. As Glenn mentioned earlier, we had a little bit of Sweet Caroline last night, so my voice may be a little bit hard. Thank you for coming today. Before I get started, let me get a show of hands. Do you keep your utilities in CAD? Okay. How many people keep them in GIS? Okay. Some of the same hands. Okay. So a couple years ago, we took over maintaining the utilities composite, and we took it over from another group. We looked at what we had and realized that we needed to provide a better solution. And so we went through a period of transforming our utilities into from CAD to GIS because it allows us to do analysis and other things. So into that, our solution drivers was innovation. CAD is very limited on what you can do. Quick select does not work the same as select by attributes or select by location. You can try to fake that, but it's not effective. We wanted to be able to provide responsive visualization, meaning changing text in CAD is very difficult. If I decide I want to change how pipes or objects are labeled, it makes it very simple in GIS. It's not something you can do in AutoCAD. We wanted to be able to analyze, we wanted to be able to summarize how many linear feet of pipe we have, how many objects, how many types of objects we have. You can do that with some block count, but if you don't follow standards and processes, then your results are going to be mixed and really not supportable. And we really wanted a single version of the truth. What we had found is historically there were a variety of maps that were produced as one-offs meant to emphasize a system or highlight certain attributes. And we went back 10 years and found objects that were missing with the expectation from the utilities that they were there. So it was very, very daunting for us, and we realized that we needed a better solution than a CAD drawing for our utilities composites. And so we made the transition to GIS, which is not difficult. It is time consuming. As Lynn said, maybe a little bit painful. You do have to jump in with both feet and be committed to it. You will reap the benefits. So for the purpose of this presentation, I'm going to focus on tools. I'm thinking about the person who has maybe a smaller budget and is not part of Autodesk's AEC collection. So you may not have Map 3D or Civil. And I want to think about the tools that even the smallest organization can afford. So we're going to be doing this using vanilla AutoCAD. I think right now we're running 2018. Esri has a free ArcGIS for AutoCAD plugin, so you can download it from their website. Very simple to install. And we're going to use ArcMap. Now I know there are open source products that you can use. But if you're an institution, if you're a higher ed institution, you more than likely have an educational sightline license that you can benefit from. So going into this, I'm going to talk a little bit about what you can do. So drawing prep, I suggest if you're unfamiliar with GIS, do as much as you can in CAD before you move to GIS, because AutoCAD, bad drafting in CAD translates to garbage in GIS, and I will just say it in simple terms. It's very important. So you need to audit your objects. You need to look at things system by system. Make sure that somebody didn't copy a block from your storm layer and put it on your sanitary layer and change the color of it. And while it prints nicely, it's not going to translate. And so when you make that transformation, you're wondering why a cleanout's missing from a line when it should be there. Well, it's because you'll find it in another system. Another thing to look for is that sometimes people draft in series of lines versus polylines. We found that was the case, that one polyline actually turned out to be 15 lines that were snapped to each other. It's just not great, and it does not translate well into GIS. And hopefully you are in the position where we are, where you have drafting standards and processes that people actually followed. So, you know, there's a lot of lessons learned. Don't learn them the painful way. Do as much as you can in CAD. So we run some data tools just to clean up the drawing once you finish auditing things. Overkill gets rid of stuff you don't need. Purge, get rid of layers and stuff you don't need. Now, we use change, and I'll tell you why. So what we had found in our CAD drawing is that they tried to incorporate 3D drafting in their 2D environment. And so we found points that were at -1 million or +1 million. And while you can probably use flatten to do this, change, you can change the elevation properties to 0. Our approach was to get the information translated, make sure it's complete, and then worry about increasing making the attribute data better. Make sure you have a manhole in that general area. Then worry about the geolocation, the elevation, the X, the Y, and the Z. Don't worry about it now. We did some audits just to make sure that there are no errors. And this will depend on your format of ArcMap, but you probably have to save your drawing into a older format. So we use 2010 for ours. You'll have to check based on what version of ArcMap you're using. And so I'm going to turn it over to Zach. He's going to talk a little bit about how to prep it for GIS.
So also real quick before we move on, I just also wanted to note on another instance of when you were talking about the versions, every time you have to go back to your AutoCAD DWG file and you make a change to it, it'll automatically bring it back up to whatever your current version of AutoCAD is. So if you haven't already done the import into your GIS shapefile, you'll have to resave it down. Like every time you go back into it, you'll have to resave it back to whatever version will be able to read it. One of the things, another tip that you'll be able to tell whether your ArcGIS version is able to read the CAD version is when you bring it in and you zoom to the layer, and if you see a blank screen, then you know that's a really good indication that the AutoCAD drawing is not going to be in the correct version. Usually the ArcGIS, the ArcMap versions keep up to date, but we're using Arc 10.1, 10.5.1, and we had to go all the way down to 2010, like Sue said. But the newer versions, 10.6, 10.7, you can probably get away with just leaving it in the AutoCAD 2018 version. So the next step is you have to make sure that your AutoCAD drawing is in a coordinate system. This is an extremely important step right here. You're not going to be able to bring a drawing in and then assign it a coordinate system in using ArcGIS because it's not going to. You're still going to have to move the data. So if you're already using AutoCAD, it's going to be a lot easier just to use these simple commands, the move and the scale and the rotate commands. You can also figure out where you need to be. A good indicator that your AutoCAD drawing is not in a coordinate system is like in the bottom left-hand corner of your drawing will be 0, 0, 0. Then you already know automatically that your DWG file is not assigned a coordinate system. So like one of the indicators to us would be, our DWG file would be somewhere in this range of the X and Ys. Then we would know, okay, well, this data is already in a coordinate system most likely, so I can probably go ahead and start the process of doing the export from CAD to GIS. If you need to do the assigning a coordinate system, the ArcGIS for AutoCAD tool will allow you to add a coordinate system, or it'll allow you to assign a coordinate system to your CAD DWG file. It'll also give you resources that Esri already has. Like that's what this imagery is. We just added the base map imagery from Esri's services that they already stream for you. And one of the indicators, actually, I think when Sue brought this in, this DWG was not in a coordinate system, and we knew this because the base map showed that it was in what, like,
it's on the equator.
It was on the
by
equator.
the Panama Canal.
Yeah, it was west of South America and out in the Pacific Ocean. So it's really important to get your DWG file into a coordinate system first. There are tons of ways that you can do this. You can, if you already have like other GIS data that's already in a coordinate system, you can assign your coordinate system to your CAD file first, and then bring it in as an X reference, and then you'll have like another base to do the move, scale, and rotate to. And once you're there, then and you've already done all the other things that Sue spoke about, then you'll probably be ready to go ahead and get started with the actual exporting. So if you're using the base versions of ArcGIS, one of the easiest tools to use is going to be the feature. What is it? The features to shapefile. It is the feature class to shapefile. That will allow you to just drag your DWG file into the wizard that it brings up, and ArcGIS kind of sees AutoCAD a little bit differently. AutoCAD DWG's files a little bit differently than what you're used to. It will assign, during the conversion process, it'll assign pretty much all your blocks will become points. All of your polygons will become polygon files. And this is what Sue spoke about a while ago, is if you have like a polygon and it's not closed, then ArcGIS is just going to see that as a regular polyline, so it'll put it under the polyline feature class instead of the polygon feature class. So if you actually need things to be closed polygons when you're doing your migration, you'll have to go make sure that all of those are closed polygons. After you have ran this tool, and at this stage of the game, there's a bunch of different ways that you can do this, actually. We took on, well, I'm not sure how we did it in the beginning, but I find it easier to just go ahead and take the DWG file and just do one export and create one shapefile. Well, actually, it's going to be 3 shapefiles. It's going to be the point, the polygon, and the polyline feature class. And then I have a basis to start kind of querying out and separating out all the different features. Utilities, this is where you have to kind of start to figure out how you want to go about doing this. In our system, we have 16 different utility systems. Like what, seven of them are water systems? Are we going to put those all into one water system feature class, or are we going to separate them out? We ended up separating them out, different story. But which kind of brings me to the next stage. Really, at this point, this is a process that's going to be ongoing. You're always going to be evaluating your data standards. And what I mean by your geometric standards is, remember when Sue spoke about, like a single polyline in CAD was broken up into 16 different line objects. Where were they broken? Setting standards for, this is especially important for utilities, figuring out how you want to start to organize that data is pretty important. If you want to if you're going to have your polylines break on nodes, and what I mean by nodes, those are going to be like gate valves and manholes and junction boxes, different things like that. Are your polylines going to break on those objects, or are they just going to be continuous through them? Are they going to break at intersections? These are types of things at this point that you're going to be able to clean up as you're going through and separating out all this data, because that is what it is now at this point, is data. What you're looking at on the screen right now is Esri's water utility schema. What is the schema? That is going to be basically your tables, all your attribute values that are going to be, it's the database that's going to be behind all of your objects. All your lines, points, polygons. You want to start figuring out how you want that information to look. This is also like where you would start to interview like all your customers, all your utility customers. Find out like what kind of data they keep in tabular format. Like, do they keep Excel records of assets and things like that? All that is information that is going to be subtypes and domain values all within your GIS. As I mentioned earlier, we have 16 utility systems. So separating out the data, or knowing where we are going to start separating out the data, is extremely important at this stage of the game. How much time are we at? We're good. So after you have sat down and decided how you want your overall schema to look, this is where you want to start going through your actual data that you exported out. There's going to be tons of information that came over from your CAD file that you may not even realize that it's even attribute information. Just some examples, we have a lot of utilities that have at least 3 different types of information just in the layer name. It's a storm drain, it's underground, and it's owned by UT. Some of them are, I don't have an example here. Some of them would say, COA, which is City of Austin. Those are attribute values that you're going to want to incorporate into your database. So when you're doing your export, you need to make sure that like line type values and layer values, especially if you've already been organizing your CAD in similar fashion like this, all that is very important information that you're not going to want to lose. So it's going to be a lot easier to query, though, in ArcGIS. The reason why you want to separate out information like this is because it's going to make your data set a lot more richer. You'll be able to do all kinds of different querying and analytics if you have all this information broken out. Another example would be we copied over some of the notes, and it has like pipe size and the valve type, material types. Those are all separate bits of information that you don't want clumped into a single attribute value. And the reason for that is then it's not going to be as queryable. You're gonna run into things where when you try and do a search, if you're trying to search for just like a single object or a single type of object, if you have all this information conflated into just a single attribute, it's not really going to search it very well. You're just going to get all kinds of information when you
inconsistent results.
Yeah, inconsistent results. Another aspect of making sure that this data comes through is when you are separating out your data into the various feature layers, the feature data sets, the feature classes. By what I mean by that is your utilities. Each of your utilities will probably be in a feature data set. You'll have different types of objects within the feature data set, feature classes that'll be pipes. We have all of our instruments into a single point feature class. You'll be able to query out the data after it's migrated, and then you can start moving it into all those different buckets. Something else I wanted to mention too is we also had a lot of blocks that had a lot of important information. I'm not sure if they came over with the regular, but if you're using like AutoCAD Map and you're able to export using AutoCAD Map 3D, you have a lot more control over what you're exporting out. And you can make sure that your block names come over, and we had a ton of information within our block names as well.
It does come up.
I'm sorry?
It does come.
It does come in with the base? Okay, so you don't need AutoCAD Map 3D. I think at this point, there's probably a lot more information, but.
It's okay. Just to echo what Zach said, you know, evaluating your shapefile data is really important, and it kind of reinforces what I said earlier about making sure you've had CAD standards, because it really does make it a lot more challenging. You know, we spent so much time. Originally, when we had done this, as you can see, Zach pointed out, we had Storm Underground UT, and I'm sure we had Storm Underground COA. And so that's how that was shown in our CAD drawing. And that made things really terrible for the transformation, because we had several hundred layers. Consequently, you could have 12 layers and everything just be thrown into it. So it really is, you know, at this point, we do understand this a little bit like eating an elephant, is like trying to figure out, how do I get out from this mess? But you know, once you've moved your stuff in here, you've created this transformation approach, you've created your standards, it should help allow you to get to where you need. And as he said, it's never ending. It always is a struggle. You're going to continue to struggle. So you need to standardize and normalize your CAD first. That is, you know, imperative. What Zach talked about, making sure your polylines are broken at objects. You know, do all the work that you can. I'm sure there's people here who can draft really well, like Zach, in GIS. My skills are a lot stronger in AutoCAD. I'm more familiar with the tools. I don't have to forget, oh, I'm not in an edit session. You know, the GIS data, you know, data manipulation or object manipulation is a lot more difficult. So definitely standardize and normalize, do what you can to try to like set yourself up for success. As we talked, you know, review your data by system. You know, as I pointed out earlier, we found things that places that they didn't belong. And you know, it's really an opportunity for you guys to really kind of look at how you're doing, and it gives you an opportunity to look and really refine standards for future deliverables. I know that most of you new projects, you're going to get AutoCAD files. I don't know many AECs that produce GIS deliverables for you out of a project. So it's very important that for future integration with projects that you really say text. It needs to be single line, insertion points, no M text in your AutoCAD deliverables. Objects need to be blocks. They need to have point insertions. All pipes need to be polylines, not closed polylines, and anything that represents structure needs to be a closed polyline. And then you can, you know, that'll facilitate moving forward as your utilities continue to grow. So we kind of wanted to leave it a little vague because I'm assuming people have specific questions. So we're going to open it up that now, if you don't mind. Okay?
Would you be able to share with us the CAD standards that you have developed based on this project?
Yes, we can totally do that. What we've done is we've created a box link that we share with all our project managers that spell out, and it's a one-page standard because the longer a document gets, the less likely someone is going to read through the whole thing and make sure that they deliver. And we wanted to keep it very simple. And I'm happy to share that. I think we also have a template that we use. We have a list of what our blocks are, and things like that. Anything that we can do to help facilitate us getting the correct information the first time, because there's nothing with utilities, especially, like finding out afterwards that maybe that pipe was installed there and maybe it wasn't. We'll be talking tomorrow in another session about some tools that we have implemented at UT Austin and some process changes that help us make sure that we get these things. We actually require an as-built after a project, but we try to collect that information ourselves beforehand.
Something else I wanted to add to that too is in terms of CAD standards, we are trying to move away from CAD. Not necessarily in the BIM world and in the space utilization world, but in the utilities world, and like our planometrics for like all of our campus maps. Like we have, I would say like 98% migrated from CAD to GIS. We're about to not be using CAD for like our utilities composite at all anymore. So.
Any more questions?
How do you designate the accuracy of the utility? What system are you using?
Are you talking about in terms of field surveying method?
Yeah.
So we're using Trimble total stations.
No, I mean on your.
Oh,
the existing, like the existing.
A or B or C or whatever system you're using.
D.
It's
D.
mostly D.
Everything that came from the original
Yeah,
CADs was
everything
D.
that came from the other file is all D to us. It's not, unless we've seen it, that's where it's supposed to be, which is, has forced the university to implement like dig-safe programs that ensures that if you're digging below 16 inches, you actually have to supposedly use a hand shovel to really find out if objects are where they are. But this is just like another reason why the sooner you can make the transition, you can start verifying the accuracy of that information. I mean, you've got to get it into a format that makes it real simple to do that. And then you could program that into your schema. Has this physically been geolocated?
That was something we added after the fact. After actually was an attribute for status.
Yeah, in GIS. And so that's the beauty of GIS is that you can grow your schema. We use the local government model, but we don't use it exactly as is. We say, why do we need that?
We're using our
version.
version.
We pare it down and we use a homegrown solution. We use it as a guiding principle, but we don't need 100 attributes if we only need 4.
Yeah, like if we went back to that slide that had the utility model, all of this stuff is attribute information, and we're probably never going to even use even half of that information for attributes. But it is still a good guide to figure out where you want to go and where to start from. Because it's easier to look at something and say, okay, well, I don't need that, I don't need that, I don't need that. This is great. I'm going to use this instead of this, versus just sitting down with nothing and say, okay, what are we going to put in this? So that's why the ESRI models the utility network, and then the I always forget the name of that one.
Which one? The network extension?
No, the local government model.
Yep.
I remembered it.
Someone had a question in the back. I think you were next.
Yeah, about deliverables of your utility map. And I imagine civil engineers are using CAD in site design.
Civil engineers are actually providing both GIS and CAD nowadays. As the customer as the customer of the deliverables, we can tell them, hey, we want this in CAD and in GIS, and they're more than happy. Doing those exports from CAD is pretty easy for the engineers typically, and usually they're also using a coordinate system also, so it would usually just come straight into your GIS.
And to add to what he said, most of our civil engineers are using civil or Map 3D, and so those will have coordinate systems. Most of our new construction requires like surveys up front, so you know they've got a lot of new information that they can feed to us after the fact. To the GIS point though, they will charge you extra for the GIS, so don't think you're going to get that for free. They will make sure they can get what they can out of you for what they deliver you. Did you have a question in the back? You good? Julius?
Have you folks figured out an easier way to transfer attributes from the DWG file into the attribute table in GIS? You know,
yeah.
Sizes, for example, they're like labeled directly.
Oh yeah. Well, what we had found that was interesting is that, you know, what we had didn't really follow any standards, and so you'd have 3 lines, and there'd be like a floating number. And so what we found, it was guesswork, like, okay, well, you know, this is gas, it's probably not 6 inches. And this is that's not 6 inches. And so it was really a painful process. I think I said a lot of colorful words about the people who came before me, and I guess they had gotten us this far, but you know, our intention is we want to move down the road to have it like network utilities and use some of the new features of Pro, and you can't do that with CAD, and you need all that information, and it is painful. We look back at you know, we open old utilities composite, and we wait for it to open, and we wait for it to open, and you look at it, and there's no, you know, expansion chamber numbers are huge, and then other things are really tiny and hard to read, and it just did not make a lot of sense to me. But you know, we had worked mostly with floor plans inside, so I don't understand the challenges of you know, that civil world until about 5 years ago, and so that was really a growth period for my team. Yes, sir, Chris.
Actually, off of that, there's a functionality, ArcGIS for AutoCAD, to plug in for AutoCAD. It allows you to kind of GIS enable with CAD data.
Yes.
Yeah, that's what we were speaking about a while ago.
Yeah.
So as far as that annotation and attributing your CAD data, it starts to kind of link it up.
Oh, okay. We'll have to explore that. Hopefully we don't have to go back that way.
For an initial data creation,
yeah.
you just go label by label.
You know, and that's true. I think that we were trying to keep this real simple because, you know, we are trying to publish GIS services for our planning department to consume in AutoCAD. I just kind of felt like if people were here, they're in AutoCAD now, and so they're kind of making that transition towards GIS, and so eventually they'll get to that comfort level where they're like, oh, I'm publishing these services, this is great. It sometimes takes a little, I feel like you gotta kind of get through this, but then you appreciate the pain you go through. But thank you for bringing that up, I appreciate that.
Did you look at the DOT specifications for utility documentation?
We have looked at so many different specs throughout this, and at the end of the day, you know, we interviewed our utilities guys, and they pretty much said, we want it to print nice. And that was really their only guiding principle, was that it looked nice when you printed it on paper. So the utilities department really was not sort of driving us to change to this. They were just like, okay, you know. And there's, you know, I don't think they still understand, you know, that we have what? 1.7 linear feet of underground piping. 1.7 million, sorry. Yeah. 1.7 million linear feet of underground piping on our main campus. And so I don't think they understand what a magnanimous job it is, like how really just overwhelming it is for us to manage. And if things aren't, you know, you can put a line on a different layer, you can color it so it looks the same, and voila. So it's been quite an interesting journey for us.
The only reason I say this is because the university butts up against, obviously, DOT projects.
Yes, it butts up against DOT, and it butts up to COA. And so at the end of the day, That is more of the planning's department. You know, we provide them with some guidance. We use professional surveyors from like SAM to do most of this work just because we don't have anyone who's an RPLS in shop. And, you know, of course, your standard drawing, you know, not to be used for engineering purposes. I kind of feel like it's a South Park disclaimer. It should not be used by anyone. You know, information is not verified to be correct. But that's, you know, and I think that as we increase our understanding of what we're working on, those things will follow.
Yeah, I work for Sam. They better be delivering to you,
Right, I appreciate that. I do. We appreciate it. So if you are keeping on top of that, then that makes my job easier because then I don't have to.
And they should be delivering it in GIS for you too.
Well, I will make sure I will make sure to pass that on. Much love, much love. I appreciate that. Any other questions? And I don't know.
Please go ahead.
Go ahead. I'm so sorry. I'm so sorry.
This question might be two parts. So first part, were there any utilities that you weren't able to successfully convert? And if not, which was the most difficult?
Well, one of the, so there was nothing that we really couldn't convert, but what we had found is there was a lot of information missing. So we have underground tunnels. And so there was a notion that these pipes went into the tunnel. And then they came out at another end. And what they did in the tunnel stayed in the tunnel. So we had a lot of work to do. We have gone down there. We're deploying some new like 3D photos, and we'll talk about some of these field collection methods where we're going into the tunnels and actually capturing that so we can verify what we've drawn up. It's been a daunting task, you know, in finding systems like, okay, we have reused water and reclaimed water, and we have ionized water, and we've got lab water, and utility air, and compressed air, and, you know, it was a giant learning curve for us just to kind of get our heads wrapped around it. Kenny is probably responsible for bringing clarity to all of that. He's been very instrumental in working with our stakeholders, working with the field crews that go out and actually asking them, because while, you know, the AD level, they know what they're doing, it's the people, you know, it's our connection to the people that are actually maintaining this equipment that makes us so effective in this endeavor.
And then if I can add, like to specifically answer the second half of your question.
Yeah, I'll let him answer the second half.
And correct me if you think that I'm wrong, Kenny, on this. All the utility systems were at some point in time difficult, but probably the one that we are even still struggling with today is the electrical and the comm utility data, because you know, we're trying to decide, you know, how are you going to represent that information in a 2D format, because you have duct banks that are, you know, a couple feet by a couple feet, and then there's conduit running through those duct banks, but it's not just one conduit. It could be anywhere from 4 to, like, you know, some of the larger ones have like 24 different conduits, and they're all different sizes. And then in between, and then in those conduit, you have, you know, you have comm lines, you have electrical lines, all different kinds of electricity. Yeah. So how do we represent that in a 2D format? And I know Kenny wants me to say this. You know, and so we're going to be trying to take those data sets and move them into a utility model. We're going to try and model the systems using some of the ESRI platform, so that when you are at like a zoomed out view, all you see is the duct bank, but then you click on a specific duct bank, and then you'll see, okay, well, that duct bank has X number of conduits, and 5 of them are 5-inch, and, you know, this many are 4-inch. And then within those conduits, you can click on another line, and then it'll break out and it'll show you all the different utility lines that are in that specific conduit that are within that specific duct bank. But that's all like modeling, though. So that's what we're moving towards. But before we could even start doing that, we had to do all of this first.
So it looks like we have about 5 minutes left. We're happy to keep answering questions, and you can see us afterwards. You start?
Just saying, how did you get buy-in from like the operations side that your map was better than whatever map they had in their trailer? That's what I'm running into. So I've done a lot of similar work, but they still always go to, well, this is Joe's red lines from this project.
There's always going to be that, and we still struggle with that every day. I think one of the things that we often have to do is, you know, we have to go out and take points and go, there's no way this can be correct. You know, a markup is just a markup. You know, another thing that we found challenging is that they used, they measured off of building faces or building envelopes, but on the CAD drawing, they had the roof lines. And so when they drafted objects, they offset from the roof lines and not from the building envelope. And so sometimes, you know, we just, I think, use a common sense approach, like, it's not there, you know, and sometimes that's the best you can do. I understand it's a challenge, and it's really frustrating. Yes, sir.
So to jump on that, what we do, our guys, is that when I created, let's say, the water map, I use the CAD underline, and then we have to locate, you know, canvas that goes out, locates utilities for us. So whenever we get a water line, we add it to our map. So about a month ago, we sat down and bought pizza for lunch, and we sat there, we showed them the maps, we had her with that iPad, collector before, and we kind of go through.
I like that approach. That's really great.
Operations guys, now they're like, well, yeah, this line is way off, or that map doesn't connect. And when they can see it, and you can see their differences, then they start to jump on.
Yes, and we've kicked around that approach. Unfortunately, like I said, you know, the utilities department is like, as long as it prints well, you know, we don't care until, you know, you hit a duck bank and it creates like $1,000 change order, and then they're like, oh, your information was wrong. So one of the things we want to start moving towards is using utility locators as well, since we have obligations to respond to dig locates. And things of that nature, but we're not paying for it, so we have to be a little bit sparing with how the funds are spent. But I'm going to wrap my head around a way to make them understand that's a value added for them. So we've got 2 minutes left. If there's no more questions, please see one of us. These guys, you might see them at the reception desk. I'm walking around all the time, and you can look us up on the UT directory and email us if you have any questions. We'll be happy to answer or help you guys, you know, make your journey a little less painful. Thank you.
Thank you.